And then we'll jump into kind of a wrap-up review so that next week when we start our week, we'll be in basically the last phase of weather. And I'll give you some options for how we'll wrap up this chapter on weather. So yesterday, when I asked if there were any questions about station models, it was dead silent for the most part. Some of the biggest things that I'm seeing with your practice that you've turned in, the most frustrating part, to be perfectly honest with you, is the amount of you who just write a number and leave it. Rarely, if ever, I can't really think of any examples from this year where we were allowed to write a number and just the number. There's always, always, always the need for units. So I know that this number 57 does not have units on it. But we're far enough along in the year where we can say, well, I think I know what temperature unit should go on this value. How about, I don't know, Will, give me an acceptable unit of temperature that I could put next to the number 57. Will, can you try that again? I don't think you're unmuted. There you are. Try it again, Will. All right, I can't hear Will. How about Carson?
Fahrenheit?
Yeah, good. We could put the unit Fahrenheit after the number 57 in this example. And then when I drop down here for dew point, it even tells me that dew point is a temperature reading as well, and we need to report with units of degrees Fahrenheit. So right off the bat, temperature and dew point, it's a little frustrating to see. Maybe only a handful of us, 3 or 4 of us, actually type our answers with units Fahrenheit. You could use Celsius, but just know that 100 degrees Celsius is boiling. So unless our numbers are really, really low, they're likely going to be in degrees Fahrenheit. Wind direction. A couple of us struggled with wind direction. This main flag, I'll call it a flagpole or a flag, this main flag here points to where the wind is coming from. So it's like a compass needle pointing which way you're going. If we look at, we'll look at this example again. Which way is the wind coming from in this example on the key? Sarah?
Northwest?
Yeah, you could even keep it pretty general. It's north-ish, and it is a little bit west, so the best answer would be northwest. And then it's these little, what did I call them? Flags, or these little indications off the end. These tell us how fast the wind is moving. And for that, we need to go to a key. And yes, when you report a wind speed, you need units. Now, many of us may not be familiar with a speed unit known as knots. K-N-O-T-S, kind of like Will's last name, but only one T in this one. But wind speed is reported in knots, but I'd be willing to accept anything in terms of a speed unit. So can anybody offer up another unit of speed that could be acceptable? How about Aiden McKenzie? Aiden, when you ride with your parents in the car, how do we report speed? How do we know how fast we're going? What units do we have?
Miles per hour.
So miles per hour would be just fine. Knots and miles per hour are pretty close to one another. So either of those units, I should say, would be appropriate. A lot of times in weather, though, they use the unit of knots. Not too many of us struggled with cloud cover, which was great. Pressure is the big one. So I'm going to demonstrate how to redo the pressure for number 1 according to the directions. The pressure is the number reported in the upper right-hand corner. So in this one, it's 107. In our assignment from yesterday, it was 987. The directions say, for the pressure, remember to add a decimal point between the second and third digit. So I'm going to go down to 987, and I'm going to add a decimal point between the second and third value. And then it says to put a 9 or a 10 in front of it, and it's got to land somewhere between 960 and 1040 millibars. So if I put a 10 in front of it, what have I done?
You've made it too high. It has to be between 960 millibars and 1040 millibars. So you made it too high.
Putting a 10 in front of it, I think that was McKinley, thank you. Putting a 10 in front of it would make it too high, so my only other option is to start with a 9. And McKinley also properly stated the units of pressure, millibars. Every value needs to have a unit, and our pressure units are millibars. So we got a question, maybe. Wait, sir, for wind speed. Wind speed, Carson, you can report miles per hour or knots. Knots are probably the, yep, thank you, Tim. Good question, Carson. Again, back to pressure. Station models try to cram as much information as possible onto them with as little clutter. So that's why we're only going with the last 3 digits in the pressure reading. Before we move on to our review of weather, or kind of start the review of weather, does anybody else have questions on station models? Especially since there were so many errors made in yesterday's practice. Steve.
So on the first example, I was confused on how you find the current weather.
Good question. So current weather is always going to be reported where my cursor is right now. So if there's nothing there, if there's no symbols, then you can just write the word none. A lot of us wrote the word clear, which doesn't make sense if it's partly cloudy, 50%. So we just have to say none. Good question. What other questions do you have? Got one coming. Pressure on the other ones. How do you find pressure on the second one? Carson, is that what you're asking? Yes. I'm not going to do it all the way for you, but I'll just start it according to the directions. We were given the value 0.46. I have to place a decimal point and then put the number 9 or 10 here so that it falls within that acceptable range. What other questions do we have?
If we correct it, can we get credit?
Always, but here's the catch. If you correct it, you have to reshare it, resubmit it. Otherwise, it's just getting buried behind old work, old assignments. So I have to get some heads up that you've made changes. Any other questions before we move into this review, which is related? If you're waving a hand in the air, I might not see it because I can't see you all at once.
Mr. Crockett.
Yes.
Sorry, I might have missed this. What's the units for pressure?
MB,
Okay.
millibars. And then Leah, to answer your question, there is always going to be the range, and it's the one given in the directions. In terms of pressure, in terms of weather, I should say, pressure is always going to be between 960 and 1040. And we can even see that on the map that I'm displaying right now, this review that we're going to transition into. All these numbers, this chaotic scattering of numbers, are all pressure readings, and they all fall between 960 millibars and 1040 millibars. More questions coming in. I'm going to create, how do I find the first pressure number? Carson, I'm confused by well, let me see if this helps. When I go to my key, the pressure value that we start with for following those directions is reported in the upper right-hand corner. So this example here is 107. So I would type 107, place a decimal point between the second and third, and then I would write a 10 in front because that falls between 960 and 1040. Good questions. All right. So we're going to begin drawing from the 1024 millibar station model over Salt Lake City. It's highlighted here. We're going to draw a line located, we're going to draw a line next to 1024 located to the northeast. And then if we were to do this on pencil, we would connect all the 1024s. The result would be an elongated circle centered approximately over eastern Utah. The line that was drawn represents the 1024 millibar line, and you can expect pressures to be 1024 everywhere along that line. If we were doing this on paper, we would repeat that procedure with the next isobar value. So isobars are lines that connect areas of equal pressure, and our interval is every 4 millibars. So we started at 1024, we would go up to 1028, and so on and so forth, up to 10, down to 1020. The point is that from the map that we started with, if we were to trace lines to connect areas of equal pressure, here's what we would get. Can anybody remember from our previous chapter what these look like or are similar to? Looks like
Contour lines.
Caleb's got the answer. Yeah, we said contour lines were areas that connected, they were lines that connected areas of equal elevation. They never crossed. Same thing's going on here with these isobars. So just a way to show what's going on with pressure. Isobars can be used to identify high pressure and low pressure. The pressure in a high area is greater than the surrounding air. The pressure in a low area is lower than the surrounding air. So we would go on to add a blue H and a red L to indicate where the pressure is higher and lower. This is a pretty simplified look at the map. But this is a review back to the notes that we took. This is important here. If you don't have your notes from earlier on, this is a repeat of what we put in those notes. High pressure regions are usually associated with dry weather because air sinks and moisture evaporates. Low pressure regions usually bring precip. So we would shade green around the L, indicating precipitation, and yellow just to represent nice dry weather. What kind of What kind of symbol would we anticipate to find on the map next to Missoula today? Somebody besides somebody who's already answered. How about Drew? What do you think we would find on the map today in terms of pressure?
Like
High or
like
low?
today, like today is in Friday.
Yeah, like today because it's rainy outside, would we expect to see high pressure or low pressure?
Probably low.
Let's have a look. We're kind of like right in between two low pressures. Right on. Cool. Okay. We'll do this review and wrap things up. So here's a weather map that looks very similar to what we just did. Question number 1. I want somebody to tell me where to click on this map where we'd expect to find warm temperatures. So now we're going to talk about temperature and pressure, going back to our notes. Maddox, could you tell me somewhere to click on this map where I could expect to find warm temperatures? Like you could name a state or an area of the country where we would expect to find warm temperatures.
Pennsylvania.
I'm not very good at, I think that's Pennsylvania, right? Yeah, okay. Perfect. So just for review purposes, the warmest temperatures are found in the warm air mass behind the warm front. So remember, this symbol is a warm front. The semicircles point its direction of movement and going to the north. Warm air is found behind it. Can somebody, I'll call on you, tell me where we'd expect to find cold temperatures? Sarah. You're muted.
Sorry, on the other side of like the blue and red lines.
Name a state. Name a state where I should click.
I don't know.
You tell
don't
me
know.
when to tell me when to stop the mouse.
Stop.
Okay. Perfect. Yes, behind the cold front. The semicircles were for warm front. The blue triangles are for cold front. Everything behind the cold front is cool, relatively speaking. All right. Somebody tell me where to click on an area of the map where you'd expect to find high pressure. How about Elise?
Somewhere around Idaho.
Like smack dab in the middle of Idaho where the blue H is. Highest atmospheric pressure is found at the center of the high pressure system, labeled with the blue H. Brainbuster time. Where is the area of low pressure? How about Ethan Stack?
Next to Minnesota and into Michigan.
Like by that red L?
Yeah.
Excellent. The lowest atmospheric pressure is found at the center of a low pressure system, labeled with a red L. Now, I'm curious to know if somebody can tell me where to click where I could expect to find some precipitation. 8th graders, if you're starting to join, 7th graders, we're wrapping up here in just a minute, so hang on, 8th graders. Can anybody unmute their mic and tell me where to click where I could expect to find precipitation to occur?
Wisconsin.
All right, so this is noteworthy here. In other words, worthy of adding to your notes. Precipitation typically occurs along and ahead of the warm front, along and behind the cold front, and always around the center of a low pressure system. So we're now getting a little more detailed in terms of where precipitation occurs. Looks like I see Victoria writing, Avery writing, Annie. Looks like Leah and Braden are writing something down. This highlighted statement is a really important one to get because we're just specifying what we put into our notes last week. Once again, 8th graders, if you're just joining, I'm wrapping up with 7th graders. We'll be done in just a minute, so hang tight. So hopefully you can see it on your screens, but there's this gray shaded area of an indication of where precipitation would occur along and behind a cold front, along and ahead of a warm front, but like we saw today, like Drew told us, always centered around a low pressure system. Here, I'll copy and paste it. Let's see. So, good suggestion, Carson. There it is. And as I move on to the next map, so the chat contains the note. Clicking on an area where we would have the highest wind speeds would be like clicking on an area of the map where the lines are closest together. So this pink shading shows where the wind would be the greatest. It's just like looking at a topographic map and saying, those lines are really close together. It's very steep there. So if I rode my bicycle down this hill, I would go really fast. Looking at this, if air moves here, it's going to be moving really fast because the pressure change is really dramatic here. And then the last map would show the opposite where winds, oh, it doesn't even have it. That was our last question. Largely a review of some symbols. Our main symbols that we'll see on a weather map: high and low pressure, warm and cold fronts. And then this note contained within the chat. What are our questions?